everybody. I'm Russell.
Hello, everybody. I'm Mika.
Do you guys want to know a fun fact? This is our fourth escape together.
Right. We actually met here at BBD about what, 4 BBD grad groups ago? And this is the first picture we ever took together.
We took it at our exec grad lunch.
No, man. I'm pretty sure we took it that one time when we went go karting, with the grads.
No, it was at the lunch in the bathrooms, remember?
Right. So we don't remember when we took this picture. However, here's the picture to prove it. We actually form a much bigger friend group called the Besties. And we're still great friends even now. Look at this picture we took last week. How cute. We met at the BBD grad program. And the grad program was where we were taught all core software skills in the form of level ups. I just want to quickly fix my mic, just 2 seconds.
Maybe it's also mine.
Probably, actually. Okay, seems like we're fine. Just 2 seconds. So, how's everybody doing? Great escape we've got going on. What's the difference between a good joke and a bad joke timing? Where's Stefan? Thank you so much for that joke. I was laughing so much.
Good?
Yes.
Okay. Woo! Speak?
Speaking.
No. Maybe by the fourth time we'll get this right.
Speaking. Speaking? Yes.
Yeah,
Sorted?
yeah, we're good.
Fair enough.
Good.
Okay, yay! Cool. So, as I was saying, we all met at the grad BBD program, or the BBD grad program, in the year of 2022. And that was where we were taught all core software skills in the form of level ups. And there was this one defining level up. Well, at least it was defining for me, in the way that it shaped our careers as well as our friendship. And that was web development. The level up was called web development, and we had to build a website. And we decided to build a friendship application. And that was where my passion for making things pretty as well as functional came from. I studied at Belgium campus and majored in software engineering, graduated with a bachelor's in computing. Will this help?
Good to go? Okay.
Okay, great. As I was saying, I studied at Belgium campus and graduated with a bachelor's of computing and majored in software engineering. And my favorite module, to no one's surprise, was web development, which makes sense now, considering the fact that I am a front end developer primarily working on websites.
Well, that was definitely a defining module for you. For me as well, but not in the same way. That was when I realized I was not good at making things pretty or functional. I still have scars from deciding to make our friendship finding website's background color yellow to prove it.
We backed you so hard with that decision.
Right? Because hear me out. Yellow is the color of friendship. And we were building a friendship finding app. But anyway, that was the end of my front end career. To be fair, I studied mechatronic engineering at the University of Cape Town, where we did no front end modules. So, can you really blame me? Thereafter, I stayed primarily back end for almost 2 years until until recently when I joined the research and development team, ATC, where I dabble with all things, but for now, mainly generative AI research and development.
Right. So to reiterate, this is our 4th year together.
I still remember in our first year working here, you did an escape talk, and that really inspired me to do one. 2 years later,
I remember when you told me when you got accepted for your talk, I was so excited for you. And then I mentioned how I wanted to get into talking as well. And then you said,
what would be so cool?
and then we said,
Let's do a talk together.
10 months later, here we are.
But how did we get here?
Right. Like, how did we think of a smart mirror?
Let's paint the picture for you. I want to do something with AI and emerging tech.
I hear you. Can you sprinkle some JavaScript in there? I like JavaScript.
Okay, so something full stacky.
Mm-mm. Something cool as well, though.
Cool.
Yeah,
What about IoT? That's cool.
I see you. Smart mirror.
Smart mirror.
Smart mirror.
Like mirror, mirror on the wall. Who's the fairest of them all?
Right. So pause. It's actually magic mirror on the wall, not mirror, mirror on the wall, but we move. Yes,
Isn't that kind of vain?
it's vain. Yeah, but it's smart, so it's okay.
Okay.
Right. So we had a dream.
We were committed.
We submitted.
And we never looked back.
We actually never considered any difficulties regarding our idea, like, how none of us know how to use a drill.
Or the fact that they don't sell the one-way mirrors. We need to build this mirror in South
Mm.
Africa. So goodbye to every YouTube and instructable videos possible.
Right. Or that a pie, a monitor, a speaker, a microphone.
And don't forget a USB-C adapter, a keyboard, a mouse, some tint, and some framing.
Oh.
For you guys who didn't see that, that's like, it's
Money,
expensive.
money, But we had a dream and we were committed.
And after a lot of stress. Hi, can you please play me a playlist on Spotify that's going to get me into the vibe? I'm going out with the girls tonight.
Please suggest me an outfit on YouTube. I need inspiration.
So, how did we build this?
Right. Like, how did we build the mirror? We'll start off with the hardware.
We watched a bunch of YouTube videos like this one and thought,
That's
doesn't
not so
look
hard. We were so wrong. The hardware portion of the mirror seemed like it was going to be the most complicated part.
Well, not really, if you knew how to use a drill.
Right. Or if you owned one.
Or if they sold the one-way mirror you needed to build this in South Africa.
But again, we had a dream and we were committed.
Okay, to recap. In order to build this, we're going to need a makeshift one-way glass kind of mirror thing.
Shaky. But okay, sure.
A monitor to be the face and display of our mirror.
Okay. Yeah, we can do that.
A Raspberry Pi to be the brains of our mirror.
Yeah, we can also do that too. Thank you. Take a lot.
Some framing so that it actually looks like a mirror.
Another shaky one, but we'll get to it.
A microphone so we can speak to her.
Yeah? Yeah.
And a speaker so we can hear from her.
Good to go. Right. So we told you guys about the hardware things. Let's talk to you guys about the difficult parts of building the mirror. Shaky's part one, the actual mirror. We've spoken to you guys so much about one-way mirrors that we haven't actually explained to you guys what they are or what they do. To give you guys context, a one-way mirror is a piece of glass that's reflective on the one side while allowing light to pass through from the other side.
Basically, it's what creates this effect. But once again, since they don't sell this in South Africa, we were going to need to improvise a little because that wasn't going to stop us from building our mirror. So I come from a family who loves cars, building them, fixing them, racing them, the works. So I know quite a bit about them. And when we had this dilemma, the first thing that popped into my head was this. It's basically a type of window film that reflects light from one side, creating a mirror-like appearance, while still allowing visibility from the inside.
So then we thought, why not just take the tint and slap it on the monitor? Good to go, right?
That could work, right? So we called my dad, and he confirmed.
Meet guy's name, who helped us to get the tint as well as helped us to put it on the monitor because we didn't believe him the first time. Moving on to Shaky's part two, the frame. So considering the fact that we had 1 week to build, neither one of us know how to use a drill or owned one, we made the executive decision to outsource.
Meet other guy's name, who graciously accepted our request to frame our monitor.
And believe me, guys, not many people would. And not many people would in a day.
So to recap, we bought a monitor with built-in speakers to be our face and ears.
We then put a Raspberry Pi on it so it could be our brain.
We then attached a window film reflective tint that gave it that mirror-like effect.
And then we framed it so it looks pretty. Moving on to the software. We're going to explain our parts of the software in a way that's easy for you guys to understand and follow. Okay, ready? Right, okay, cool. So for the front end, I built a JavaScript middleware layer on top of the Magic Mirror framework running on the Raspbian environment. It connects to the backend, processes responses, and reformats them into content that's easy to read on the mirror. The modules are readily available and customizable so that it doesn't disrupt the overall system. Got it?
So for the back end, I created a custom MCP server with fast MCP that connects to Spotify, YouTube, and Google APIs. This let me create custom tools for playing songs, delivering affirmations, and showing YouTube videos. Then I created an AI agent using LangChain agents and OpenAI's GPT-04 Mini so it can tap into these tools and respond in a really dynamic way. Got it?
Got it? Right, neither did we. So, to make lives easier for us and now for you guys, we split the production into 7 iterations.
You mean our 7 dwarfs?
Yes, 7 dwarfs, magic mirror on the wall, Snow White. You guys get the picture. Cool. Starting off with our first iteration, we're going to call him Grumpy. Grumpy has everything to do with the environment setup. And by environment setup, I'm referring to the operating system that exists on the Raspberry Pi. And getting that set up was actually quite simple. We watched a YouTube video for about 10 minutes, followed all the steps, and once the Raspberry Pi operating system was up and running, we moved on to the framework. By framework, I'm referring to the Magic Mirror framework, which is the open source modular smart mirror platform. It's basically the framework that makes our mirror smart. It's composed of a number of default modules that you can view as plugins, like the weather module, clock module, calendar module, etc. And the Magic Mirror framework lives on GitHub. And inside of its repository, You'll find a number of notable resources, but my favorite ones are the Node.js server because yay, JavaScript, and the Electron app, which is what helps to render the modules onto the mirror. So then we got to work. We had to run a couple of commands. And one of the first commands we ran was git clone to obviously install, well, clone the repository. Then we needed to download Node.js. And after downloading Node.js, we ran the command npm install to install all the packages that the framework would need in order for it to run.
Wait, what's npm install?
That's a good question. That's a good question. So npm installs like you telling me, hey, go into the kitchen and fetch all the ingredients you're gonna need to make this meal. Right? Similarly, I'd be telling Node.js, hey, go and fetch all the packages you'll need in order to make this framework run.
Oh, so it's kind of like pip.
Whatever. Yeah, sure. Okay, moving on. We ran the two commands npm install to install all the packages, like I mentioned. And then we ran npm run start to start the framework. And that concludes Grumpy. So we've got the operating system up and running. We've got the framework all set up. And we've got all the default modules in place. Now we're done with Grumpy. Happy?
Happy.
Great. Moving on to our next iteration. We've got Happy. The modules that came with the framework were default modules with default values. And we wanted to customize them and possibly even add some more. And by customize them, I mean change some of the variable settings. You know, like what city should the weather module look at, or what time zone should the clock module observe? And the config that housed all of these modules is actually quite easy to follow if you're into JavaScript. Here's a screenshot of what the modules look like. The weather module, as well as the calendar module, are objects. And each of these objects have properties that you can use its values to manipulate to give you the context that you want. For example, with the weather module, we have the latitude and the longitude properties, and you could give it the values that you want so that it can observe the city or area you want. Similarly to the calendar module, we toss in a URL way at the bottom over there that will give you all the public holidays that you want to observe for that specific area. Okay, nice, cool. So we then did some research to see what other modules existed. And trust me, guys, there's a lot. And if you wanted to install some of these modules, you needed to run git clone, considering the fact that every module that existed outside of the default modules were their own repositories. So the default modules have been customized. Yay. And now we have a different idea as to how we're going to install some of the other modules for our mirror. Yay. That's Happy. I'm actually feeling really tired.
Goal same.
So we're going to move on to our next iteration, Sleepy. There's only so much that you can edit on the config in terms of customizing your modules to your heart's content. And some of the other modules did need some help. For example, the weather and the clock module were quite easy to customize. But then we also wanted to add a YouTube module, which would then get a video URL, which would play a video immediately. So we needed to do two things here. Firstly, we needed to build a server-side script. And this server-side script would provide us with a video URL that would then be sent to our client-side script via API endpoints. And then we needed to add logic to push that URL as a notification to our YouTube module, but this is all better explained with some code. So this is our client-side script. We expose an API endpoint called last, and what last does is that it retrieves information from the backend, and then we extract a URL from the object's response, and then we send a notification to our YouTube module that will play the video immediately. Moving on to our server-side script. We created a rudimentary backend that would generate a YouTube URL, inject that into our object, and send that as a response to our front end. So when we tried to generate the URL the first time just to see what video we'd get, we got rickrolled, which is really funny. Right, so we added more modules that required extra customization. We then created a rudimentary backend that would generate a YouTube URL, send that to our front end, and then we got rickrolled. And that, my dear friends, concludes Sleepy. So Sleepy is cool, but he's not dynamic or smart, TBH. We wanted to make Bashful, which is our next iteration, even cooler. And by cooler, I mean we wanted to add a voice component to our mirror so that it would fire off any questions that we would ask it. Here's how we went about that. In our server-side script, we created or added a speech recognition library. And this library exposed us to two functions. Firstly, the microphone function that recorded our audio. And secondly, the recognized Google function, which took our audio and transcribed it into text. And that concludes just the first portion of our voice components for Bashful, which then Bashful was almost done. But we wanted him to be smarter and cooler.
So we added an LLM to take in the user's voice commands and then respond.
What's an LLM again, just by the way?
Good question. So LLMs are AI models that are trained on massive amounts of data. By doing so, they're able to generate text so that they can answer questions, hold conversations. You get the idea. And by integrating this into our mirror, we're able to interact with it a lot more naturally, almost like we're having a conversation. To connect our LLM to the backend, we made use of OpenAI's chat completions function, where we passed in the user's input as part of the messages parameter, and we made use of the GPT-4 model here. And that's Bashful, everyone. So now we have a smart mirror that's able to take in voice commands and respond. That's cool, but Bashful is still kind of dumb because he couldn't really do much. And we wanted our mirror to do cool things. You know, start with the basics like playing songs on Spotify, accessing YouTube, and accessing and updating our calendar schedule. But really, the dream was to be able to level up my morning affirmations. When I said, play my morning affirmations, I wanted it to be able to go through my podcast that I had saved, find one that was motivational and inspirational, and then play it. Ooh, and to be able to go through my calendar and then, based on what I'm doing for the day, suggest a makeup look. And then go to YouTube and find a tutorial for that makeup look. And then play it on my mirror so I can use it to help me get dressed in the mornings. And then have this all controlled through voice commands and agentic AI. So with that dream in mind, we got started with Sneezy. We needed some way of connecting and integrating YouTube, Spotify, and Google Calendar into our mirror so we could do all the cool things I mentioned. Enter Model Context Protocol, MCPs for short. MCPs gives our AI model a standardized way of connecting to external data sources, APIs, and applications. So instead of creating custom integrations for all of these applications, MCP provides us with a common language so that any AI model can use any AI tool that follows this language. We start off with the LLMs. They can understand and generate text in a conversational manner, but that's all they can do because they don't have access to any tools or knowledge. That's where the MCP server comes into play. It contains all the functions that the model needs to perform actions and get data. But the MCP server can't talk directly to the AI model and vice versa. This is where the MCP client comes in. It acts as a translator between the model and the MCP servers. This allows our model to use all the required tools it needs from the server. But how? The Model Context Protocol. This defines a standard JSON-based way to define tools and resources, call these tools and return their results, and share resources like documents and files. When working with MCPs, you have two options: create your own and run it locally, or use a hosted managed server. Examples of this is Zapier, Claude, or GitHub MCPs. Creating the Zapier MCP was pretty easy. We chose this one, by the way, because it already had custom integrations to YouTube, Spotify, and Google Calendar. So it was pretty easy. All you had to do was configure your client. In our case, we made use of OpenAI's API, and then add functionality to your server in the form of tools. So now, Amr is able to take in voice commands and perform cool actions through Zapier MCP servers. And that wraps up Sneezy. Sneezy worked, but he mostly used keyword matching to determine which tools to use. So he couldn't take in very complicated commands, and he couldn't do multiple tool calls. Like this, for example. Tell me about my schedule and find a good makeup tutorial on YouTube on it. Sneezy didn't know that he needed to use Google Calendar and YouTube tools from this, and he couldn't make use of both tools, hence multiple tool calls, for one user request. But we want our mirror to be smart.
Gentic smart.
So that we can give it complicated commands that are not just keyword matches and that uses multiple tool calls. So construction for Duck began.
The quick one, actually, what's the difference between the LLM that we used in Bashful versus the AI agent we're going to use in Doc?
Valid. So remember how Sneezy couldn't take in complicated commands? With an AI agent, when I asked to check my schedule for the day and suggest a makeup look, the agent is able to go through all the tools it has access to on the server, realize it needs to use Google Calendar first, and get the results for what the person is doing on that day. Based on the results returned, analyze it and suggest a makeup look. Then find a relevant tutorial on YouTube for that makeup look, and then play it on Amara.
Okay, cool.
To create our agent, we made use of the create React agent function from LangGraph. And we did this to solve our multiple tool calling issue. By the way, a React agent is one that's able to reason before acting, hence React. Bye, Doc. Doc was great because now we can handle complex prompts, but sadly, Doc still fails us. Because if I ask my agent to add a calendar event for tomorrow, the 22nd of August, 2025, that was when we did this, that says dinner with friends at 8 p.m., my agent says it's successfully done. But then when I go to my calendar, we see it's not actually added. So even though our mirror is smart,
Gentic smart.
our Zapier MCP servers aren't working very well. Since this is a server that was technically in beta testing at the time, and since this is a managed server, so we don't have access to this code, there's not much we can do about this. So that left us with no choice but to come up with Dopey. Dopey uses our own custom MCP server. Dopey uses 3 custom MCP servers to be exact. One for Spotify, one for Google Calendar, and one for YouTube. To make this a bit easier for everybody to follow, I'm going to explain how MCP protocols work in code, first with a basic example. Then we'll jump into the code that we used for our server. So first and foremost, we create our server. We then need to add functionality to our server, and we do this in the form of tools and resources. So for tools, you say mcp.tool as our notation, followed with a function that performs the actions we want this tool to perform and returns the results we want it to return. For resources, we do something similar, except here we use the mcp.resource notation, followed with a function that returns the relevant data we need. Now we have a server with tools and resources. So all that's left to do is start our server. We do this by running mcp.run. Thereafter, we need our AI model to be able to interact with the server. We do this by creating an MCP client, and this is how you would create the client. This is how you would call the tools from the client. You'd make use of the client call tool function. In this case, we're calling the tool greet, and we're passing in the input parameter name. Okay, getting back to Dopey. If I were to show you guys all the code that we created for these servers, that would be a whole talk on its own. So I'm just going to show you how we created one of these tools, and hopefully you guys get the idea.
And if you guys don't get the idea, it's fine. It's okay.
To make Dopey more robust to conversational user inputs, we made a tool that was specifically taking in a user's prompts and then finding and playing the relevant YouTube videos, play-related video. It takes in the user's prompt and then passes it into the search YouTube function. The search YouTube function does what it says. It searches YouTube and finds the most relevant videos. We then take these relevant videos and pass it into the select best video function. No guesses what that one does. It selects the best video. But we make use of an LLM here to select the best video. If we had a bit of a deeper look into what the search YouTube function does, you'll see it calls the relevant YouTube API. We pass in the user's request as part of the parameters, and then it will return a list of max results videos. In this case, that's set to 5, with the ID, the title, and the description of the video. We then take this list and pass it into the select best video function. This will then get an LLM to take both the user's request and the selected videos and determine the best one. We made use of an LLM here because of context. The LLM is able to take the context from the user's request as well as the returned results and pick the best video. We found that this worked a lot better than just using the first selected result from the Search YouTube API. Okay, now that we have a bit of a better idea of how MCP tools work, hopefully, these are all the tools we created for our custom mirror. For Spotify and YouTube, we went beyond a simple search and play. We designed these tools to be able to handle very complex commands by inserting LLMs and sometimes agents at key points in the code where we felt that it needed more intelligent reasoning and classification. By doing so, we were able to get much better results than what we did from the hosted Zapier server and be able to give it like a lot more complicated commands. With Spotify in particular, we personalized the experience. Instead of doing a global search, the tool would first check the user's saved content when responding to a request. This was important because we realized that although the tool was able to take in very complicated commands, it often returned content that we weren't interested in or didn't even know. So by prioritizing personalization, we were able to get a lot more usefulness out of it. Finally, here is how we added everything all together and integrated it into our AI agent. We added all our connections to the relevant MCP tools from our servers. We then wrapped those functions as tools with a description and added them to a tools list. And lastly, we configured our AI agent with this tools list, the model, and the agent description. Dambo.
We're now going to show you guys a little bit of a demo on our mirror, and hopefully everything works out fine.
For you guys to see that this is actually a mirror and not a monitor, I mean, we can see it. Can we please switch on the lights for just like 2 seconds if they can see me waving? Yay! Can you guys see it's a mirror? Like, hi. This would be a nice time to take a picture, but it's fine. Okay, we can switch the lights back off now. Thank you. Everybody pray to the demo gods. All the technical issues should be done now, so this must just go well.
Oh, goodness.
Good.
Hi.
I'll say what you're saying and then
Thanks.
you just say it. Yeah.
Hi, please can you create me a calendar event for 8 a.m. doing my nails and 9 a.m. seeing my sister?
So she asked our agent to create a calendar event for 8 a.m., something with nails, and then 9 a.m. seeing my sister. You'll see that we have the agent or the user request at the agent response, and then we're waiting for our response from the agent. It would have been nice to be able to show you guys that this actually worked, but because we're sharing the screen from the monitor, we can't do that. So believe us, this
Just trust us, bro.
works. Yeah.
Right. Based on my calendar events, can you suggest me a YouTube tutorial? Thanks.
So she asked, based on my calendar events, can you suggest me a YouTube tutorial? Which you can now see on the screen. So this is also running on a Raspberry Pi, so it's not the fastest, and it's also connected to my hotspot, so it's really not the fastest. Just ask another question.
Hi, can you play me my favorite song on Spotify? Something by Beyonce. Oh, wrong song.
What? Thank
Oh, I
God.
love the song.
Trying to choose against the makeup look.
That's great. Can you suggest me a makeup look on YouTube?
Found the truth beneath your.
One more time, the voice command.
Can you suggest me a makeup tutorial based on my calendar event?
Okay, well, that's makeup tips.
In this video, I'm sharing 10 awesome DIY makeup life hacks you've never seen before.
Can I try? Hi, Dopey. Based on my day, can you please suggest me a makeup tutorial on YouTube? Okay, so for some reason, the voice commands don't want to work very well, but you guys can see that it does what we said it does. Thank you, Kat.
Bye, Dobby.
Yes, I have to get it in this sauce. The next big one I get, I do it in the butter.
Do you want to stop it?
I already stopped the
Okay.
Okay.
Ready?
Yes.
So this was a backup demo in case this didn't go well, but I don't think we're gonna have time
Just
to
in
play
case.
this.
Hi, Dobby.
We built a mirror!
You and we dreamed a dream there, hey? Oh,
But we did it.
we did.
Well, mostly. There were a few things we didn't get to, like camera integration.
Right. And also multilingual capabilities.
And doing this on a full length mirror. We could have done those though, with more time and a lot more money.
So, was the mirror really a vain idea?
Maybe.
Mm-mm. It was actually an excuse to take automation to the next level.
Right? So AI is already intelligent. We know this. But what it lacks to make it personal and useful to us is personalization and integration. That's what gives us true efficiency.
That's also what sets it apart from assistants like Siri and Alexa that are only able to take simple one line commands. For example, set a timer for me, play me a song on Spotify, play me a video on YouTube. And normally all of these are done within one application.
With MCPs, we can go one step further. Not only do we get AI driven actions that are personalized to us, but we also get coordination across multiple applications and tools at once. Like with this mirror, for example,
Hmm.
I love podcasts and makeup tutorials. And I save all of these onto my YouTube watch list and my Spotify saved list. But when it comes time in the morning for me to listen to a podcast or try out a makeup tutorial, I never have time to go through them and try it out.
At least you save your podcasts and tutorials. I stay doom scrolling in the mornings, just looking for the perfect makeup tutorial. And then when I do find one, which I've already wasted time on, I now want to look for the perfect song on Spotify to curate the perfect vibe. But if we could integrate all of this into our personal lives so well and easily, imagine what this could do at work.
So, guys, if there's one thing you should remember us for, it's that we're dreamers and we're persistent.
So the next time you have a crazy or wild idea that pops up into your head, don't shy away from it. Matter of fact, find someone that's just as crazy and just as persistent as you are.
And you can also build a magic mirror.
Just remember it's magic mirror on the wall, not mirror, mirror on the wall.
Okay,
Okay,
bye. Does anybody have any questions? I don't know if we have time for questions.
Do we have time for questions?
We have 3 minutes for questions.
Okay, we have a question up there.
I don't know. Should we take the mic? But will online hear you if you shout? Okay, I'll repeat it. That's a good point. Okay.
Yo.
Cost me.
Oh,
That's-
that's actually a really
That's
good
a great
question. That's a really good
question.
question. You can go ahead and ask it, yeah.
So we put in like I think 300 rand
Yeah.
into OpenAI. And when I checked it this weekend, because we didn't want this to happen where it runs out of tokens now, we only used like $1,
Yeah,
$2
$1.
max. So
Yeah.
it's really cheap. And we've been testing this a lot and
Yo.
failing and trying a lot. So yeah.
Any other questions?
It's also really hard to see, so I don't know if you guys have questions.
Okay.
There. Okay, this time I'll remember to repeat the question.
Hello.
Oh.
So earlier you mentioned camera integration. Do you have any security concerns about security attacks and exploiting if you should hang this mirror in a bathroom?
Very good question. I think in that case, so currently this is connecting to OpenAI, but if we were to do camera integration, the main idea for that for us was to actually just pick up our faces and then personalize. For me, have a specific type of assistant, and then for her, have a different one. But if we were to do that, I would run the LLMs locally. So we can use a mini agent or a mini LLM. It's not very powerful, but it's good enough for this kind of use case so that we wouldn't have any issues where it's connecting to the internet and security.
Thanks.
Hi, great presentation. I just want to know what OS are you running on the Raspberry Pi?
We're running the Raspberry Pi's native operating system. It's called Raspbian
Oh,
or
okay.
Raspbian OS.
Thank you.
You're welcome. Oh, time's up, guys. Sorry. Thank you, guys.